Today we can discuss the topic about derivation of temperature function and shape function n for one-dimensional heat conduction element. The generalized form for this kind of problem is T is equal to A0 plus A1 into x. According to this problem, I considered one bar element which has two nodes. The nodes are 1 and 2, which has the length of L. But the node 1 has the temperature of T1 and the node 2 has the temperature of T2. So, the next step, I have to convert this generalized form it into matrix form. So, here I should be aware about what is A0 and what is A1. Those are global or general coordinates. So, next step, how do I convert this form it into matrix form? So, I can easily convert this as like P is equal to what is the A0 coefficient and the A1's coefficient. First, I write the coefficient of A0 and A1. So, A0 has 1 and the A1 has x. These two coefficients. After that, I may assign the variables which are A0 and A1. Likewise, I can write the matrix form of the considered linear equation. Now, after finding this matrix form at node 1, what happens the temperature, because node 1 has the temperature of T1, node 2 has the temperature of T2. So, the T is equal to T1 at node 1. But what is the distance? Yes, here the distance is x is equal to 0. The distance, yes, x, here it started from 0 and it ended with L. So, the length of the bar is L. So, that what about node 2? Yes, T is equal to, at node 2 temperature is T2, but x value, the node 2 has the length of L, so x equal to L. Likewise, I can get the parameters values from this bar and node values from this bar. Okay, after that, substitute these identified x value and t value on the corresponding equation. X value, yes. For identifying the temperature 1, I substitute this x equal to 0 in the corresponding equations. Here A0 plus A1 into 0. If I apply the first condition, so T1 is equal to A1. And then what about T2? I can substitute T2, x equal to L. So A0, the x value is A1 into L. So the T2 has the equation of A0, here A0, okay, A0 plus A1 into L. Likewise, I can get the two equations from the identified boundary conditions. So what about my next step? Yes, see. What about next step? We should move to identify the matrix of the next equation from the previous. I identified T1 and T2 value. Okay, T1 is equal to A0, T2 is equal to A0 plus A1 into L. From this, I can convert these two equations into matrix form. Yes, how do I convert? Let's see. Yes, the first equation and the second equation are having T1 and T2. So, here I write T1 and T2 is equal to the first. What is A1 value? Let's see. How do I write? Here you see T1 is equal to A0, but it does not have any other element A1. So, A0 is 1, A1 is equal to 1. And then, according to second equation, A0 1 and A1 has the variable as coefficient as L. So, A0 1 0, here A0 1 L. Likewise, I can convert this into matrix form. Let's see, how do I write? Yes, so as previously explained, the terms 1, 0, after that 1 L. And then what about my variables A0 and A1? It is a variables. Likewise, I convert the available equation into matrix form. But I should identify the coordinate values which are A0 and A1. For the reason I move this into the left hand side. What happens? The 1, 0, 1 L in inverse form. So I can transfer from this side to left hand side, means I may utilize the inverse matrix. After that it is to T1 and T2. But the inverse matrix, how do I convert this? Yes, the inverse matrix have the formula of here I consider this A, this I mean A, B and C, D. How do I convert? Yes, I consider A, B, C, D. Inverse means first I can write the formulas like 1 divided by A into D. Okay, A into D minus what happens the other term? Yes, B into C. B into C. After that, what is the next step? Yes, now I can move to convert the matrix form. Yes, now interchanging the places. Here, what happens? Yes, A, the place of A, the D. Here, the D. Okay, the place of A, the D moves, and here A, and then here C, here B. Likewise, I can transfer the elements. Okay, is it correct? No, here CD is not correct. So how do I change? Let's see. Yes, the A, but I keep this B as the same place, but minus B, and here minus C. Likewise, I can change the places and change the signs with respect to matrix problem. Okay, here now I can utilize the same mathematical formula for my next step. A0 A1 is equal to 1 by A into D. What happens? 1 divided by AD minus BC. According to our problem, A is 1, D is equal to L. So here 1 into L, L minus B into C. BA is 0, C is equal to 1. So this may be written as like L minus 0. After that, in D, what D? L is the D and minus B. Here we are having 0, so minus B I written, so minus 0. After that 1, the same I written, but here I introduce minus symbol, minus 1. After that, here 1. Likewise, I can rewrite the equation. After that, I can recollect T1 and T2 and place here, which is the formula for the inverse matrix conversion. After that, I can move to find the A0, A1 matrix from the available form, which is 1 by L into L minus 0 minus 1, 1 into T1, T2. Likewise, I can get the, now I have to have what is the next step? Next step, now I found A0, A1. Now I can substitute this into our initial equation. What is our initial equation? Let's see. Our initial equation is T is equal to 1x into A0, A1. Here I can substitute A0, A1 matrix value. So now you can see. So what happens if I substitute the things? Yes, if I substitute the values in the initial equation, means T is equal to 1x. After that, 1 divided by L into 1, 0 minus 1, I mean L, here L minus 1 into T1 T2. Likewise, I can recollect the things. Now I can simplify this. So now 1 by L common term I take it outside. Here 1 x of that L 0 minus 1 and then T1 T2. Like this I can write. After that now I want to simplify this. Here 2 cross 1 cross 1 2 columns 1 matrix. Here also 2 cross 2. Now how do I convert this? Yes. So 1 by L 1 into L. So here L 1 into L. Here I write L. After that x into minus 1 L minus x. And then again 1 into 0 I get 0. After that this x into 1. What happens here? 0 plus x into T1 T2. Likewise I can get the equations. Next, what about our step? Yes, let's see. Here I got the things. I get this thing 1 by L is into the inside of this matrix, so that the form L minus x divided by L. After that x by L into T1 by T1 T2. Likewise I can write. Now I can simplify this form into N1 N2 into T1 T2. So now I can get the N1 and N2 are the same function. So what is N1? N1 is equal to L minus x by L. And what about N2? N2 is equal to x by L. So these are all the shape function I utilized. What about the temperature function? T is equal to, I can write as like N1 into T1 plus N2 into T2, which is the temperature function I got from this matrix. N1 into T1 and plus N2 into T2 I got as the temperature function. And then N1 is equal to, I got from this N1 is equal to L minus x by L, N2 is equal to x by L. So the second equation is the temperature function, and the first equation is shape function, which is the derivative for temperature function and the shape function of one-dimensional heat transfer problems. Okay, one-dimensional heat transfer problems.